Hello class, welcome back to capital budgeting. So we've done a number of problems together. We began with some problems just practicing using our present value and future value tables. We calculated retirement savings using future values. We calculated lottery using present values. And then we calculated some business projects and which ones we should accept. So you might see that I still have problem 27 here on our board, and that is deliberate because I'm actually going to work through problem 28 today, which refers to this data point. So just to refresh, in problem 27, we were given two different projects to consider. Project A, it cost $280,000, but gave the company cash inflows of $56,000 a year for 8 years. And they wanted a 16% return on their money. Project B cost $380,000. It gave the company $74,000 of inflows each year, and they only wanted a 12% return on their money. So we calculated the net present value and we found that project A was negative, so it should not be accepted, and project E was positive and it would be accepted. So problem 28 asks us to calculate within an estimated range what the internal rate of return is. What is the internal rate of return? Well, it is the actual percentage that would make the cash outflows equal the present value of the inflows. What number, what percent would make this zero? What percent would make this zero? So I will show you how to do the calculation, but I want to point out two things. First of all, this is something you can do in Excel. So if you like Excel, if you look at the top ribbon on your Excel spreadsheet, you will see formulas. And under formulas, you will see financial. And IRR, internal rate of return, is one of the formulas. Because we could spend hours trying to try again to get this to equal zero, trying all different percentages here. So we're not going to do that. Secondly, I always say step back and think about the numbers. Make sure they make sense. So we know that this was a loss at 16%. So the internal rate of return to make that zero will be what? Something less than 16%, right? Okay, and likewise here, this was positive at 12%, which means the actual internal rate of return is going to be greater than 12%. So, how are we going to do this? We're going to simply take the project cost here, $280,000, and we're going to divide it by the annual inflow, and that's going to give us 5 for project A. So now we're going to look at our present value of an annuity table. We know that project A lasts 8 years. So we're going to go down 8 years, and we're going to look to see where is the number, which 2% are between. That gives us the number 5. And the answer is between 10 and 12%. So the internal rate of return for project A is somewhere between 10 and 12%. Does that make sense? Yes, it's less than 16. Now, project B, we'll do the same thing. 380,000 divided by 74,000. That's going to give us 5.14. That's 9 years. We will go to our present value of an annuity table. We'll go down to 9 years. Okay, where will I find 5.14? I will find it between let's see, 12 and 14%, which makes perfect sense because it's probably around 13%. And that, folks, is how we will calculate internal rate of return for purposes of this course. So we're going to just find the two columns where these numbers fit. So again, we're solving for the percentage. We know the actual number of years, so we're looking for the percent. And that's how we calculate internal rate of return. And that's the rest of what we will cover from capital budgeting. I hope you have a great day. I will see you all soon.